In this video, we will be learning to apply Markov chains to solve real-world problems. So here is an example. Suppose that the sons of right-handed fathers, 90% are right-handed and 10% are left-handed. Of the sons of left-handed fathers, 30% are right-handed and 70% are left-handed. Assume that right-handed and left-handed fathers have sons in equal numbers. Suppose that in the initial generation all of the fathers are right-handed. Determine the percentage of their grandsons that are left-handed. So in order to solve this problem, first of all we would write a transition matrix. Let me call this transition matrix as A, and I would label these right-handed father as like right-handed RH and left-handed with LH. So this is like, say, if this is representing current generation, then we would have this transition matrix with RH for the next generation and LH for the next generation, next state. So we have to fill in this information. If the father is right-handed, the son would be right-handed, right? So the chances are 90%, so we would plug in here, so 0.90, and then the sons are left-handed, the chances are 10%, so 0.10. Similarly, if the fathers are like, say, left-handed, so 30% chances their son would be right-handed, so 0.30, and 70% chances that the son would also be left-handed. So this is the transition matrix, our A. And then we are also given that in the initial generation, so let me represent as V0. 0 means the initial generation. So the percentage of the left-handed and right-handed, so right-handed and left-handed people. So it says all fathers are right-handed, so 100% are right-handed, so it's a 1. So there's no left-handed person there in the initial generation. So this is called a probability vector, right? So in this case, V0, so representing the initial generation. So we have to now answer the question, so what is the percentage of the grandsons that are left-handed, right? So basically, we have to find V2. So V0 is the initial generation, so V1 would represent like the next generation and V2 represents the grandsons, right? So we have to find this V2. And the relationship is that, so if we have to find like, say, V1, so first we have to find like, say, V0 times A, and then for V2, so we have to find as like, say, V1 times A, or this can also be done by using V0 times A square. So either this would work or this would work to answer this question. So let me go with this way. So first I find like what is the percentage of like, say, sons, and then what is the percentage of grandsons, right? So in 2 steps. So first let's try like, say, what is the percentage of sons there, right? So this is representing fathers, then this is sons, and this is grandsons. So first go with the V1. So V1 would be equal to V0. V0 is this matrix or vector or one row matrix. So that 1, 0. So for a moment I don't label them RH, LH. I know that this 1 is for RH and 0 is LH. And then similarly for A is 0.9, 0.1, 0.3, 0.7. So when I multiply them, so this would turn out to be like, say, 0.9, and then 0 times 3 is 0, 0 plus 0.9, so, and 0.1. So this is the percentage of sons. So again, this would be right-handed and left-handed. So 90% of the sons would be right-handed and 10% would be left-handed. But we have to find for the grandsons for V2. So similarly, V2 would be V1 times A, and V1 is this part here. So 0.9, 0.1, and then with the multiply matrix A was like 0.9, 0.1, 0.3, 0.7. Multiply them, and you would get 0.9 times 0.9 is 0.81 plus 0.1 times 0.3 is 3, and then 0.09 plus 0.07. So this would turn out to be 0.84 and 0.16. And again, this is your right-handed grandsons and left-handed grandsons. And our question was the left-handed, the percentage of the left-handed grandsons, right? So then for this one, so this is your answer here. So this one, so left-handed would be 16% in terms of percentage. This one. So that's your answer. 16% of the grandsons would be left-handed.